Okay, so this is the second video in our review for the Molecules to Atom Unit 1 Physical Science test. In this part, I want to go back over reading a chemical formula. Some of the key ideas to remember as we're looking at this is each element has a unique symbol which represents a shorthand for scientists to communicate the elements or information to one another. Combinations of these symbols can be used to communicate information about compounds, and eventually we are going to use them to talk about different chemical reactions. Changing subscripts in a chemical formula will change the compound that we are working with. So we do not ever change the subscripts when we are working with our compounds. The coefficient in front of the chemical formula will tell us the number of molecules of that compound which are present. And again, this becomes much more important when we're dealing with chemical equations. Right now, we're just trying to get you to understand the different parts of these things before we start writing out formulas for how we mix different chemicals to get new compounds and products and things like that. So we've looked at the periodic table. We've said that the periodic table represents all of our known elements and predicted elements. And if you notice as you're looking at this periodic table that the elements can be represented by one or two letters. See, all of these here are a single letter, but then you've got some double letters and shorthand for the element. We don't want to write out krypton every time we want to deal with this. K, uppercase K, lowercase r is how we're going to use our shorthand. I want you to pay attention. Depending upon the periodic table you have, you're going to have a varying number of these three-letter elements here that are unknown or have not been named, necessarily for sure. They're elements that are either still in investigation or still under discussion for one reason or another. We aren't going to deal with that. I picked a periodic table that had very few of these. I think in our textbook we have more. It doesn't really make any difference. We're not going to deal with them. Each element starts with a capital letter. Look at all of them. It's just like the beginning of a sentence. It starts with a capital letter. The beginning of your elements all start with a capital letter. If it has a second letter, that second letter is lowercase, and this is really important because this is how we determine the separation of elements when they're strung together in a big row. If I put lithium and beryllium and sodium and magnesium in a big row, that capital letter is going to signal to me, hey, this is a new element. Li, that's one. Be, that's one. Up, there's a capital N, that would be the beginning of my next one. So if I have a single letter, if I did boron, carbon, and nitrogen all together, notice they're all capitals. Those capitals tell me, hey, new element here. So think of it just like reading a sentence. All right, so let's try a simple one. So as we take a look at this, this is the chemical formula for carbon monoxide. Capital C, capital O, remember toxic gas we discussed in class. So you can see on the periodic table that there is nothing here that matches this. If you look, cobalt is capital C, lowercase o. Capital C, lowercase o. That's not what we have here. We have capital C, capital O. So capital C is carbon, and capital O is oxygen. So this tells me I have one atom of carbon and one atom of oxygen in this element. So I have two elements, one atom of each of the elements are bound together to form this compound. Let's try another one. NaCl, capital N, lowercase a, capital C, capital L. Well, here we go. I have sodium, Na, capital N, lowercase a. That C tells me I have a new element, and that new element is chlorine. So this is sodium chloride. This is the chemical formula for table salt. We've talked about that before. let's get complicated here. All right, so let's just read the elements and figure out the types of elements. So I have a capital C, a capital H, so that's two separate elements. I have a capital C and a lowercase l, that tells me it's the third element. And indeed, I can check on my periodic table. I have carbon, that's the capital C. I have hydrogen, that's the capital H. I have Cl, capital C, lowercase l, chlorine. That's the third element. So here I have three elements in that compound. All right, take a look at this one and try it for yourself. NaNO3. Try it for yourself. Okay, so as we look at this, I have three elements. Here's a capital letter, there's the capital letter, and there's the third capital letter. So I have sodium, I have nitrogen, I have oxygen. And if you need to pause this video as we go along, go ahead and do that to practice. So 2 elements in this first one, 2 elements in the second one, 3 elements in this one, 3 elements in this one. Let's try another one. Up, there we go. NH4OH. Take a moment, look at it. How many different elements are present in that formula? Okay, so this was a little bit tricky. Hopefully you said 3 elements are present. Here's my capital letter for N. That's one. Here's my capital letter for H. That's another. Here's my capital letter for O. That's a third. But here's another hydrogen. Now it doesn't make any difference the way this is written. That H and this H are the same. So there are 3 separate elements. There's nitrogen, oxygen, and hydrogen in there. All right, let's look at another one. Even more complex. How many different elements are represented by this complex formula? How many different elements are represented? Remember, look for the capital letters. And hopefully you said 3. Nitrogen, that's that capital N. Hydrogen, it's in 2 places. And carbon is the third. And remember, we saw this when we looked at the sugar molecules, when we looked at some of the things with the hydroxide molecules, the OH. They don't have to be written the same. It doesn't matter. You look for those capital letters to differentiate one element from another. All right, there's the last one. See if you can get it. Again, 3. Barium, Ba, bromine, Br, and oxygen. Here's barium, here's bromine, and there's oxygen, and you're going to want to get used to looking around the periodic table for these things. All right, let's do a real quick review of terms. An atom is the smallest particle we can divide matter into and still have the same properties of the largest substance. If we look at silver and gold, we can divide silver and gold down to these atoms. Both atoms have protons, neutrons, and electrons in them. But it's that atomic structure that matters. If we break these down into their electrons, protons, and neutrons, I can't tell the difference between an electron from the gold atom and an electron from the silver atom. They're the same. Both electrons are the same. The protons are the same. It doesn't matter. And recall that the number of protons in the atom is what determines the element itself. Okay, so gold had an atomic number of 79. It has 79 protons. Silver has an atomic number of 47, has 47 protons. So these atoms are very specific. All right, element is a matter which cannot be broken down into simpler substances. Recall that our periodic table is our list. So if we need to check, that's the first place we're going to go look, is to look for those 2-letter codes. Can we find it on the periodic table, 1 or 2-letter codes? A compound is matter which is composed of 2 or more elements bound together, and so if we take this atom and we bind it together with other things, then we form a molecule, and here's some different examples. And the word molecule and compound are used interchangeably. We'll explain a little later why there's a subtle difference between those two, but it's not important right now. Subscript is a number written below the line. In chemistry, this number follows the element symbol and is written slightly below the line. It indicates the number of atoms of that particular element. A way to remember this is sub. Sub means below. You can think of submarine, which goes below the water. Coefficient is a number written in front of our chemical formula. It indicates the number of molecules of the compound which follows. And we can relate this to math class. When we have a coefficient in front of our variable, for example, if we say 2x, it tells us how many x's we have in that formula. A way to remember this is co means with. So the number is with the chemical formula, and it helps tell us how many molecules of that formula we have. Let's do some practice. Okay, so CO2 has no coefficient with it, so it's understood that there's one of these molecules present. There's two capital letters, so we know there's two different elements here. That's a subscript. Look, it's below the line. So that means there's two oxygen molecules. Carbon has no subscript. That means it's understood to be one carbon molecule. So this is the carbon dioxide molecule, one carbon, two oxygen. Let's go through another. There's a coefficient in front. That means I have two water molecules. So I have two of these molecules. Each molecule has two hydrogen. There's the subscript, and no subscript after oxygen, so one oxygen. So here's a single water molecule, two hydrogen, one oxygen. However, that coefficient tells me I have two of them. So there I have. And so if I look at this, I have a total of 4 hydrogen and 2 oxygens, and we can tell that from the chemical formula too. Here's another formula. Take a look. How many capital letters do we have? I see 3. That means there's 3 elements in here. One of these, 1 carbon, 1 hydrogen, and yep, 3 chlorine. And here is the molecule. You're going to get used to seeing different ways of representing it. 3 chlorine, 1 carbon, 1 hydrogen. Let's try another one. Take a look. Again, you should see that there are 3 elements in that. 1 sodium, 1 nitrogen, 3 oxygen. No coefficient, so that means we only have 1 molecule. There it is. 1, 2, 3 oxygen, a sodium, and a nitrogen. Again, don't worry about the model itself so much. I just have to pull what I pull from the internet. So here we go. Look at this. How many elements are there? How many atoms in each single molecule are there? So you should have come up with 3 distinctly different capital letters. So there's 3 elements. There's 1 nitrogen, there's 1 oxygen, and then there's 1 hydrogen here and 4 hydrogen there. So in a single molecule there are 5 hydrogens. Let's take a look at that. Here we go. 1, 2, 3, 4, 5 hydrogen, a nitrogen, an oxygen. But this coefficient tells me, that's right, I have 3 of these, so I have 2 more. So this is what that chemical formula represents. All right, a little more practice. When we're given a coefficient to figure out the number of atoms in a particular, it should say compound, we multiply the coefficient times the subscript. So this should say particular element, sorry. When we're given a coefficient to figure out the number of atoms of a particular element present, we multiply the coefficient times the subscript. So there it is. So if I have 2 of these, remember this means 2 molecules. Each molecule has 2 hydrogen and 1 oxygen. So I do 2 times 2 gives me 4 hydrogen, and 2 times 1 gives me 2 oxygen. Try another one. How many carbon are present total? So I have 2 elements. Two elements in the compound. Each compound is made up of 1 carbon and 2 oxygen. I have 6 of these present though, so I have 6 times 1 gives me 6 carbon. 6 times 2 gives me 12 oxygen. Now try again. How many molecules are present? Look at the coefficient. 4 molecules are present. How many sodium are in a single molecule? Look, there's no coefficient, no subscript, so we understand that to be 1 atom of sodium is in each molecule. So how many sodium molecules are present? Multiply the coefficient times the subscript. 4 times 1, so 4 sodium atoms are present. Alright, try this one. It's a little tricky, but try it. How many molecules are present? That's right, you look for the subscript, 2. So there's 2 molecules present. How many elements are present? That's right, look for the capital letters. So there are 3 present. Nitrogen, hydrogen, and carbon. This hydrogen is a duplicate. If we were going to figure out how many atoms of nitrogen we have present, take a look. That's right, 2 times 1 gives us 2. And how many atoms of carbon are present total? 2 times 6 gives us 12. If we were going to figure out hydrogen, we could. You would multiply the 2 times this 2 and the 2 times that 5, and you would add them together. But that is beyond our test for this unit. We'll come back to that skill. All right.